The universe is a vast and mysterious expanse, whose true extent remains largely unknown. Researchers continue to uncover astonishing phenomena and peculiarities in a space filled with otherwise enigmatic nothingness. This nothingness, in fact, accounts for more than anything else in the cosmos, filling the spaces between visible celestial bodies. Recent findings in quantum physics suggest that this emptiness could be the primordial source of all matter. Despite these revelations, the concept of nothing and the voids that stretch across the universe continue to baffle scientists, particularly the mysterious Boötes Void. Located in the constellation of the Bear Keeper, the Boötes Void stands out not only because of its sheer size but also its peculiar nature. This vast expanse, often referred to as the Big Nothing, measures an astonishing 330 million light-years in diameter, creating a gaping hole in the fabric of space. The void is significant because, despite being surrounded by countless galaxies, it appears almost devoid of matter. This enormous gap, stretching far beyond our reach, is one of the largest and most enigmatic voids ever discovered. The Boötes Void is not the only such anomaly in the universe. Smaller voids exist, like the Barnard 68, a comparatively tiny region just 0.25 light-years across. Barnard 68 lies 500 light-years away in the constellation of the Serpent Bearer. But the Boötes Void's dimensions, stretching 330 million light-years, make it a truly unique and mysterious feature in space. This void is classified as a supervoid, a term used to describe a much larger than usual gap in the cosmic structure. Voids, such as the Boötes Void, were first identified by researchers in the 1980s. Using a new method to create a 3D model of the universe, astronomers, led by Robert Kirchner from the University of Michigan, discovered that galaxies were moving faster the farther they were from Earth. As they analyzed the data, they noticed something strange. At a distance of about 700 million light-years, a vast region appeared devoid of galaxies. Initially, scientists thought it was a mistake, but upon further investigation, they realized this nothingness was real and not an edge of the universe. Researchers soon identified that the Boötes Void contained roughly 60 galaxies, even though there should be at least 2,000 galaxies in such a vast area. This discovery raised further questions. Why do these few galaxies remain isolated in the void, when most galaxies are found in clusters? What is the nature of this void, and how did it form? Theories about dark matter and its effects have since gained prominence in the search for answers. In the broader context of the universe, voids are not unusual. In fact, around 80% of the observable universe consists of voids, regions where there is little or no visible matter. While smaller voids like Barnard 68 are relatively common, the Boötes Void is remarkable because of its sheer size. It presents a unique phenomenon of nothingness on a cosmic scale, which some researchers now believe could be composed of dark matter. This type of matter, which does not emit visible light, can only be detected by its gravitational pull. Dark matter, which makes up a significant portion of the universe's total mass, could be an integral part of the voids. In dense regions, like galaxy clusters, dark matter exists in higher concentrations, creating a stronger gravitational force. This could explain the sparse presence of galaxies in the Boötes Void. While most of the region is empty, dark matter is still present and may influence the motion of the few galaxies within it. The formation of such voids is tied to the early stages of the universe, with researchers often referencing the idea of a primordial soup in which the first molecules began to form after the Big Bang. Quantum fluctuations during this early period led to small disruptions in the distribution of matter, which, over millions of years, gave rise to the first stars, planets, and galaxies. However, some spaces remained empty. These empty spaces, or voids, could have evolved as a result of these primordial fluctuations. Modern theories suggest that galaxies are arranged in a vast, interconnected cosmic web, with galaxies, stars, and planets hanging on long filaments of dark matter. This filament-like structure could explain the distribution of galaxies, with dense clusters forming at the intersections of these cosmic filaments. One such example is the Hercules Corona Borealis Great Wall, the largest known structure in the universe. However, the Boötes Void dwarfs this Great Wall, with dimensions over 30 times larger, highlighting the truly massive scale of the void. The concept of voids in space shares similarities with natural phenomena here on Earth. Just as one might observe empty patches of space in an underwater environment or in a meadow, similar forces may be at work in the cosmos. Variations in temperature, mineral composition, and other environmental factors could influence the formation of these cosmic voids. In space, dark matter and the gravitational forces it exerts may shape regions where galaxies are absent, creating voids like the Boötes Void. While the Boötes Void initially appeared to be completely devoid of galaxies, subsequent studies using advanced telescopes revealed that there are indeed a few galaxies scattered throughout this vast expanse. This discovery challenges our understanding of voids and suggests that even regions that seem empty may contain hidden structures. The Boötes Void is not a static, unchanging feature of the universe. It is part of a larger structure, a void supercluster. In this supercluster, several smaller voids have merged together, creating an even more massive and intricate void system. Researchers have observed that dark matter density is lower in smaller, less massive galaxies, and much higher in larger galaxy clusters. These variations in dark matter density might explain the peculiar distribution of galaxies within the Boötes Void. The question of whether the Boötes Void has existed since the Big Bang is also being debated. Some cosmologists believe that the void was much smaller in the early universe, possibly only a small patch of nothingness, which then expanded and grew over billions of years. This theory suggests that the void may have been a part of the universe's primordial structure, which was established right after the Big Bang and has continued to evolve ever since. While much has been learned about the Boötes Void, there is still much to uncover. Researchers continue to investigate how supervoids like the Boötes Void fit into the larger structure of the universe. Their findings could reshape our understanding of the cosmos, from the formation of galaxies to the role of dark matter. The study of voids offers a glimpse into the fundamental workings of the universe, a puzzle that scientists are far from solving. One particularly exciting discovery in the search for cosmic phenomena involves white holes, hypothetical counterparts to black holes. While black holes are known for their immense gravitational pull, which devours everything in their vicinity, white holes are theorized to expel matter and energy instead. Despite numerous studies, no white holes have been conclusively observed, although some researchers believe the discovery of unusual gamma-ray bursts could point to the existence of these strange objects. White holes are theorized to work in the opposite direction to black holes. Where black holes suck in matter and energy, white holes are thought to expel them, possibly creating a reverse event horizon. While this theory is still speculative, the idea that black and white holes could be connected in some way, such as forming a wormhole, has captured the imagination of many researchers. Some even suggest that the Big Bang itself could be linked to the concept of a white hole. The search for white holes continues, with some experts suggesting that the existence of these objects might one day provide a new perspective on the formation of the universe. However, the theoretical nature of white holes presents challenges, as their existence would seem to contradict some fundamental principles of physics. Despite these challenges, scientists remain hopeful that one day, the mysteries surrounding both black holes and white holes will be unraveled, offering new insights into the cosmos. The study of black holes and white holes is just one aspect of the broader investigation into the nature of the universe. As new discoveries are made, the questions that arise only deepen our curiosity about the cosmos. From supervoids to the theoretical existence of white holes, the universe remains an endless source of wonder and mystery. The discovery of supervoids like the Boötes Void raises deep questions about the structure and origin of the universe. The Boötes Void, which stretches across a staggering 330 million light-years, is not an isolated phenomenon but a fascinating example of how vast regions of emptiness exist within a universe that is otherwise filled with galaxies, stars, and dark matter. These supervoids, composed of transparent and undetectable dark matter, challenge our understanding of the cosmos. Dark matter does not emit light, but its presence is inferred by its gravitational effects on the visible matter in space. The Boötes Void's strange emptiness is, therefore, not truly empty at all. It is made of dark matter that interacts with other cosmic phenomena in mysterious ways. As scientists delve deeper into the nature of these supervoids, the growing understanding of dark matter is becoming crucial. The complex gravitational forces at play in these voids suggest that they could have formed from the primordial soup of the universe shortly after the Big Bang, evolving over billions of years into the immense structures we observe today. Thanks for joining us at Space Lab. Don't forget to like, subscribe, and hit the bell for more cosmic discoveries. Until next time, keep exploring the universe.